Good day, young aviation enthusiasts. Welcome to Flighty Airline Facility Tour. My name is Engineer Brian Gonzales and I am the supervising engineer for this airline. I'm so excited to have all of you here with us today to learn more about airplanes and how they fly. As we tour the aircraft, we will also discuss the theory of airplane flight and discuss the different forces that keep an airplane in the air. By the end of our tour and presentation, I hope you will have a better understanding of how these amazing machines work and appreciate the science behind the art of flying. So fasten your seatbelts and let's get ready to take off on an exciting journey into the world of aviation. So kids, how many of you rode an airplane before? One, two, three, four. I see four hands. So for those who haven't, have you seen birds and how they glide in the air? This is what inspired the creation of flight. First, let's go back to the history of flight. The history of flight is all about people trying to figure out how to fly like birds. A long time ago, people tried to make machines that could fly, but they didn't work very well. Then in the 1800s, a lot of people started making different kinds of flying machines, like hot air balloons and gliders. Finally, on the 17th of December 1903, two brothers named Wilbur and Orville Wright made the first successful airplane flight. Since then, airplanes have become a very important way for people to travel and explore the world. So, what are airplanes? Airplanes are special machines that can help us travel through the air. The purpose of an airplane is to make travel faster, more efficient, and more comfortable for people to transfer goods quickly from one place to another. They are made up of different parts that work together to make them fly. So, what are the parts of an airplane? An airplane has many parts, but some of the most important ones are the wings, the power plant or engines, the fuselage or also known as the body, the cockpit, the empennage or the tail, and finally, the landing gear. Probably, all of you are wondering and curious about the different purposes of each part of an airplane. The wing is like an airplane's big wings that help it lift up into the air. The power plant. The power plant is the airplane's big engine that makes it go. Fuselage. Fuselage is like the airplane's body that holds everything together, such as the wing, the engine, the tail, the landing gear, the cockpit. The empennage. Empennage is like the airplane's tail that help it keep stable in the air. The cockpit. The cockpit is where the pilot sit and control the airplane. Finally, the landing gear. The landing gear is like the airplane's leg that helps it land softly on the ground. Before an airplane can travel through air, it needs to take off. For an airplane to take off, it needs to go down a long runway. As it moves faster and faster, the wings start to generate lift. This is a special force that helps the airplane rise up into the air. Once the airplane is high enough, the engines or the power plant keeps it moving forward. How do airplanes stay up in the air? Airplanes stay in the air because of something called lift. The wings of an airplane makes them lift off the ground. So as the airplane moves forward, the shape of the wings. This is the shape of the wing. If you cut a wing, this is what you can see. Typical airplane, the shape of it is like a teardrop. The wings of an airplane are what makes them lift off the ground. As the airplane moves forward, the shape of the wings causes air. As we move through the air, the wing causes air to split up. One air is faster over the top of the wing. As you can see, moves faster than the bottom, which makes a straight line. This creates a force called lift, which keeps the airplane in the air. So before an airplane can travel through air, it needs to take off. For an airplane to take off, it needs to go down a long runway. As it moves faster and faster, the wings start to generate lift. This is a special force that helps the airplane rise up into the air. And once the airplane is high enough, the power plant or the engine is what keeps it moving forward. Therefore, how do airplanes stay up in the air? Airplanes stay up in the air because something called lift, as mentioned earlier. The wings of an airplane are what makes them lift off the ground. As the airplane moves forward, the shape of the wings causes air to flow faster over the top of the wing. You can see, imagine this is the air. It moves faster over the top of the wing than the bottom. This creates a force called lift, which keeps the airplane in the air. Does everyone still keep up? Or are there any questions? Oh, someone's raising their hand. Okay, go ahead, Stella.
So how do the wings generate lift?
Oh, that's a very nice question. Okay, imagine you have a toy airplane like this. The airplane has special wings called airfoils that help it fly. If we cut a wing, you can see the airfoil. The airfoils are shaped in a way that the air move faster over the top of the wing than the bottom. As you can see in this model, there are many different shapes of an airfoil, but commercial airplanes mainly use the teardrop shape. The faster airflow will result in a lower pressure, and the slower airflow creates a higher pressure. This makes the air pressure on top lower than the bottom of the wing, and that creates a force that helps up the airplane lift up into the air. To understand this better, you can do an experiment with your hand. If you stick your hand out of a moving window and tilt it up, the wind will push your hand up, and if you tilt your hand down, the wind will push your hand down. This is because the shape of your hand makes the wind move faster over the top of your hand and slower to the bottom of your hand. I hope this makes it clear. A scientist named Daniel Bernoulli figured out that as air moves faster, like the top of the wing, its pressure decreases. Explain why the air moves faster over the top of the airplane wing and slower under the bottom. Take this model closely and you will understand. And the amount of lift the plane gets depends on the things like the size of the wing, the shape of the wing, how fast the airplane is going, and the angle the wing is tilted at. However, the airfoil also generates a downward force called drag. It is because of the air resistance. This is important to consider when designing airplanes because it affects how much power is needed to keep the airplane flying. So, how does an airplane fly? We need to consider the four forces of flight. They are the lift, the weight, the drag, and the thrust. I'll tackle first the lift. Lift is what keeps the airplane up in the air, and it's created by the shape of the wings. The wings are special because they make the air move faster over the top, which creates a force that lifts the airplane up as tackled earlier. Second one is the drag. Drag is like a force that tries to slow the airplane down as it moves through the air. It is caused by the air pushing against the airplane. Third is thrust. Thrust is what makes the airplane go forward, and it is made by the airplane's engine. The engines use a special mix of fuel and air to make the airplane move forward. And finally, weight is the force that pulls the airplane down towards the ground. This is like the force that keeps us on the ground. When an airplane is flying, the lift and the weight needs to be balanced. So if the lift is stronger, the airplane goes up, and if the weight is stronger, the airplane goes down. Also, the thrust and drag also need to be balanced. And if the thrust is stronger, the airplane goes faster. And the opposite happens if the drag is stronger. The airplane slows down, but it keeps on moving forward. When an airplane is flying, all of the forces needs to be balanced, just like the lift and the weight. So if the lift is stronger, the airplane goes up, and if the weight is stronger, the airplane goes down. And the thrust and the drag also needs to be balanced. Therefore, if the thrust is stronger, the airplane goes faster, and if the drag is stronger, the airplane still keeps moving but at a slower pace. In 1686, a scientist named Sir Isaac Newton presented his 3 laws of motion. The first law of motion states that if something is moving, it will keep moving unless something else is going to stop it. So for an airplane to keep flying, it needs to keep moving forward, and the forces of lift, weight, thrust, and drag needs to be balanced, as mentioned earlier. And if any of this becomes unbalanced, the airplane will start to slow down or change direction. And the second law of motion talks about how much force is needed to move an object. This is important for airplanes because they are heavy and needed a lot of force to lift off the ground and stay in the air. The amount of force needed depends on how heavy the airplane is. So if an airplane is very heavy, it needs a lot of force to lift off the ground and stay up in the air. Finally, the third law of motion talks about how every action has an equal and opposite reaction. This means that when an airplane engine creates thrust, it also creates an equal and opposite force of drag. This is important because it affects how fast the airplanes can go. And if the airplane's engine can generate more thrust than the force of drag, the airplane can go faster. But if the force of drag is too strong, it will slow the airplane down. So when pilots fly an airplane, they use different controls to move it around the air. The yoke, pedals, and throttles help them adjust the angle of the wing, the power of the engine. This helps the airplane down, left, or right. The controls that move the airplane up and down are called elevators. They are located on the back of the airplane and can tilt up or down to change the pitch of an airplane. The pitch is how much the nose of the airplane points up or down. The rudder is another control that helps the airplane turn left or right. It is also located on the back of the airplane and can tilt left or right to change the yaw of the airplane. The yaw is the side-to-side motion of the airplane. The ailerons are controls that help the airplane tilt one side or the other. They are located on the wings and can tilt up or down to change the roll of the airplane. The roll is when the airplane leans to one side or the other. So when the elevators tilt up, the airplane will pitch up, and when they tilt down, the airplane will pitch down. When the ailerons tilt up on one wing and down on the other wing, the airplane will roll to one side. And finally, when the rudder tilts to one side, the airplane will turn in that direction. Airplanes can fly long distances by using special engine and carrying enough fuel. They fly at a very high in the sky where there is less air resistance, which makes them more faster and move more easily than flying through at lower height. The airplane's design helps to make it move through the air smoothly and make it use less fuel. So let's tackle about the center of gravity. It is very important for flying long distances. Think of a toy airplane that you want to balance on your finger. The exact spot where it balances without tipping over is called the center of gravity. If the center of gravity is in the wrong spot, the airplane will be very hard to control. It's like this. Pilots have to make sure the center of gravity is in the right place by loading the airplane properly. By loading means that every section of the airplane is balanced. So finally, you have gone through your dream destination and you're wondering, how do airplanes land? When an airplane lands, it gradually slows down by adjusting the angle of the wings and the amount of power from the engine. The pilot also uses controls and landing gear to make the landing more smoother. There you have it, folks. I hope you learn and understand the basic concepts of airplane flying. And once again, this is Brian Gonzales, and I hope to see you soon in the aviation industry. And some of you may be working with me in the future. That's all, folks and kids. Thank you very much.